And now, obstacle avoidance.
Yeah, we're just going to move away from the whole indoor part of the airports thing, because there's lots of outdoor parts of airports as well.
There are.
And obstacle avoidance and airspace planning, that's probably something you want to do. You want to avoid your obstacles, and you also want to make sure people don't build new obstacles in your airspace.
That's right.
So the first thing is, the example we're going to talk about is done by Finavia, the Finnish Airport Authority.
Okay.
Yeah.
And they're responsible for all the airports in Finland, are they?
Exactly.
Yeah.
And there's a few high places in Finland.
Yes.
So what they wanted to do is they wanted to extract the high areas around the airports and map them out for people. So when you're planning your air routes and stuff, you have an idea where not to send your airplanes. So this is basically what they're doing. They're analyzing the ground model. They're taking LiDAR data to analyze the ground model, and then they're producing the maps. So this is a fairly straightforward workspace. We use a lot of the point cloud tools. Point cloud filter mostly is to basically extract all the points above a certain elevation threshold. Mm-hmm. So you just want to see the high places. You don't want to see the low places.
Right. See, yeah.
So and that's the example of the output. So you can see I don't know how to pronounce this, Kemi Airport, but there's quite an area in the northeast there that they really want to avoid.
Right.
And this kind of makes it easy when you're, to give this to people and show them so when they're doing their planning work, they just know what to avoid rather than having to look through contour maps and such.
Exactly. So they can easily see where not to send planes.
Yeah, and the heat map works really nicely, right? So
yeah, nice.
Okay. The other thing you can do is you have the obstacle limitation surface, and now this is a Vancouver airport, and there's been a lot of construction in Vancouver recently. Mm-hmm. And I live in Richmond, which is out by the airport, and there's a lot of construction going on there. Yeah. And you want to make sure with all this construction that you're not sort of intruding into the airspaces. So what they've done is they've generated sort of obstacle limitations on their airspaces, and they check with the planning. If somebody wants to build a tall building, they've got to make sure they don't intrude into the airspace. There's a certain buffer.
Mm-hmm. I know we also did this for McLaren Airport in Las Vegas.
McCarran.
Yeah,
Airport,
McCarran. That's it.
Also a city that's being built up quite spectacularly.
Yes. So. And there's actually a tower that was being planned, and the airport used FME and this precise thing that Dave's talking about to make the argument to council that if they actually put this tower there, the capacity of the airport would be negatively impacted. And so as a result, they didn't build it because the airport is the lifeblood of Las Vegas.
Yeah, you want the people and their money to keep
going. That's right. Yeah. So,
yeah. So, I mean, and the basic process was you can get your flight obstacles from Excel data. So you use the capability of FME to work with different data sources. So we read from Excel, we output to HTML reports. We can also write out that information to Oracle database. So it doesn't matter what your data is in, we can make it work. We can all make it work together. Okay, so airspace visualization, you can also visualize your control areas, your ILS flight paths and stuff, which gives you a good idea what's going on at the airport. So the beauty of the visualization is FME supports visualization engine. So we support the Unreal Engine, which is the game engine that makes really nice 3D. Yeah. We also output to Cesium, which is an online 3D mapping that can give you the ability to visualize massive data sets very quickly. Yeah. And of course, Google Earth, which is the old standby.
Yeah. And also I3S, which we saw previously, but for some reason it didn't make that slide, but that's me. And so, so Esri I3S is the other one. Yeah. Oh, here we go. There we go.
It was coming up. Yeah. So I3S is kind of cool in that it's got levels of detail. So as you zoom in and out, the different details turn on and off, and that also makes your data set
so we support.
To deal with.
Yeah, so we support the three big sort of global 3D visualizations. So we support Cesium, Google Earth, of course, and I3S, and they all have this ability we're seeing here where you zoom in, you get more detail. When you zoom out, you get less detail. Yeah. Okay.
So here's when it comes to 3D data, why inspect it when you can experience it? And that's the key, is that the 2D maps only go so far, especially with folks who aren't sort of map aware. They're not used to it. But 3D data, you can grasp 3D data. You can grasp relationships in 3D data that are very hard to see in 2D data. So if you let people visualize things, all of a sudden they know what they're looking at. They go, you get much better feedback.
Yeah, yeah. And the picture on the left is interesting because those mountains actually were also imported from a data set by FME. So we actually built an Unreal data set that had the real mountains, and then we decided to put a floating building in the middle of the water. But all this was integrated with FME just because we can read so many different types of information. Of course, if you put a building with imported data on the location it's going to be, you could actually, when you look outside the windows, you could actually see what the person inside the building would really see. So,
yep.
And that's the beauty of being able to integrate this data and throw it into a system like Unreal.
Yeah, and if you're building something like a hotel, and where the visual quality, your outside visual quality is one of the things you're selling, that is something you can sell to people, right?
That's right.
Or you can plan ahead of time.
That's right.